Okay, exercise 6C, triangles. So in this lesson, we're going to just talk about the basic, property of triangles, and then we're going to use the basic property of triangles to solve some geometrical problems. All right, so it's kind of like a revision exercise from year 7. So he kind of like knows a bit about triangles, and we do need to know some general properties of triangles that can help us to solve some mini like geometry problems. And this knowledge can be extended later in more complex sort of shapes. So it can be a combination of triangles, quadrilaterals, and other shapes together. All right, so firstly, a triangle is three-sided shapes. So everybody knows this. From the primary school studies, this is pretty straightforward. So we've got three-sided shapes. It's like a polygon. A triangle basically is a polygon with three sides. With triangles, a few things you need to know that we label the triangle. Actually, we label all the shapes with the capital letters. So like A, B, and C. If the sides are different, in that case, we're just going to label that with like different marks. All right, just marking the sides are different to each other. We can also use the angle to mark, the marks to, to label the angles as well. If the angles are different, we need to use different marks as well. Okay. Otherwise, if you're using the same sort of marks, then it just means the angles or the sides are equal to each other. All right, so for triangles, a couple of things that you need to know is for the angles that's inside the triangles, like inside here, those angles are called interior angles. Okay, why it's called interior angles because they are just the angles inside. Okay, so it's pretty straightforward. So the angle here, the angle there, and this angle here are just called interior angles. Okay. So whenever someone asks you, hey, what's the name of those angles? They're just called interior angles. Now, what is the exterior angle of a triangle? If you extend, okay, a line. So for example, if you extend the sides BC in either direction, doesn't matter which way, okay? If you just extend it, like for example, if I just extend it like this, then you can see there's an angle here that's formed by the angle there. Okay, so these two angles, there's a special name for that, which is called the supplementary angles. They add together equals to 180 degrees. The name of this angle is actually called the exterior angle. So one is interior, which is inside the triangle. The other one is just the exterior angles. Okay, exterior angle. We can have different exterior angles, depends on how you extend the lines. Okay, so we can extend the line like this. We'll have an exterior angle on this side. We can extend the line like this one here, so we can have an exterior angles there. All right, so this is just a few like vocabulary that you need to know for these triangles here. Now we need to move on to the classification of triangles. We can classify the triangles using two different systems. Okay, so the first system is we classify the triangle by the side length. Okay, pretty sure or majority of you should know what does that mean. Okay, classified by the side length. So that's the first classification of triangles. The first one is when all three sides are all different, like the example I just showed you previously. If all three sides are different, the name of the triangles are called the scaling triangles. All right, so they're all different size. None of them are equal to each other. Okay, so we've got sides, and these two sides are different. Alright, so that's triangle ABC. The name of that triangle is called the scaling triangles. Okay, the sides here, the angle here is different to the angle there, it's different to the angle here. Alright, so that's the first one. The second one is when we have a triangle that's two sides are equal to each other. Okay, only two sides. Okay. Pretty sure you already know the name of the triangles here. If two sides are equal to each other, then we actually call these triangles the isosceles triangles. Okay, now we call this is the base of the triangle. This is the apex or the vertex. All right, and we've got two base angles are actually equal to each other. All right, that's the properties of the isosceles triangles. Okay, isosceles triangles. Alright, so we've got the first case is when we've got a scaling triangles when the sides are all different. And the second case is when we have like two sides are equal to each other. As you can see here, two sides are equal to each other. Alright, and we call that isosceles triangles. The properties of isosceles triangles is you have one pair of equal sides, and you've got the base angles are actually equal to each other. Okay, and that's why it's called the isosceles triangles. Alright, so the last one, I'm just going to move the triangles up a bit, okay, so I have some space. Alright, let's just move this one over a bit above here, and I'm just going to move that triangle here a bit over as well. Okay. Alright, cool. So I've got a few space here. Alright, so the next one is when all sides are equal to each other, when all three sides are equal to each other. So in that case, we have something called equilateral triangles. And the angles inside are also equal to each other as well. And they all equals to 60 degrees. Okay, the reason why they're all equal to 60 degrees is angle sum of triangle is equal to 180 degrees, and I've got three equal angles, so therefore 3 times by the angles, okay, is equal to 180, so therefore each angle is equal to 60 degrees, all right, 180 divided by 60, and we call that triangle is the equilateral triangle. Oh, wrong spelling. Okay, equilateral triangles. Lateral means like, sides. So this word here means sides, and they've got equal sides. Okay, equilateral triangles. So that's pretty easy. Year 7 sort of like, revision. The next one is we can classify the triangles by angles. So previously we classified this, the triangles by, side lengths, but this time we can classify by angles. Okay, or the size of angles. Okay, I should say the interior angles to be more specific. All right, so we'll classify by the interior angles, not the exterior angles of the triangle, just the inside angles. Okay, all right. So the first one, we're gonna have a triangle that's called acute angles, where all angles inside triangles are acute angles. Okay, so all angles acute angled triangles. So A, B, C. So angle A, angle B, and angle C are all acute. Okay, so that's called acute angle triangle. All right, next one is when we have one angle that's more than 90 degrees, which is like an obtuse angle. You can only have one angle that's more than 90 degrees. You can't have like two angles that's more than 90 degrees, otherwise the entire angle is going to be more than 180 degrees, which makes no sense, all right? You can't have a triangle like it. Just basically you can't form a triangle like this. So if one angle, doesn't matter which one, if one angle is obtuse, alright, so in that case we can call this as the obtuse angled triangle. Okay. Alright, and then the last one is the right angle triangle, which is pretty famous. You guys have already learned the Pythagoras theorem, and in Pythagoras theorem we're using right angle triangles. Alright, so that's pretty easy as well. And we have one right angles. Think about it, can we have two right angles inside a triangle? Let me know if you believe you can draw a triangle with two right angles inside. Okay, I'm pretty sure you can't. Otherwise you don't have any sort of like angles that you can draw for the next one, for the third one. The total angles is equal to 180 degrees. Remember these. Okay, so this is just a little summary about the classification of triangles. Alright, so once we know this one here, then we need to move on to two special property of triangles. And then you're going to use the two special property to solve some question. We're going to see some question, and I'm going to practice some questions with you guys as well. Alright, special properties. Alright, so the first special properties of the triangle is the angle sum of the triangles are 180 degrees. So no matter what you do with the triangle, it's always equal to 180 degrees. I'm pretty sure that I have sort of like proved using papers, cut and paste it, cut all the angles out and paste all the angles together. and then eventually I'll show you that the angle joined together is equal to 90 degrees, 180 degrees. Don't know what's happening to this line here. It just doesn't want me to join the triangle. That's really strange. Okay. Alright, so I'm going to try my best to form a triangle. Okay, alright, any triangles here? So we've got angle A, angle A, angle B, angle C. The first property is angle sum of triangles, okay? Angle sum of triangles is always equals to 180 degrees. This is very, very important. It doesn't matter what triangles you have, that's for any triangles, and then it's always 180 degrees. Now remember I proved in class, I actually show you guys by drawing a triangle and I cut the angles out and I join the angles together, and then eventually that forms like, a straight line. Okay, I hope you still remember this. I do have another way to show you how to prove it. So what we can do is we can construct a line that is parallel to the line that's indicated right now. So I'm going to construct the line at this point, okay? And that line is actually parallel to the base, okay? Parallel to the base means they are, if you think about the property of the parallel lines, that just means the distance between the two lines are always remain the same. They will never intersect. I'm just going to draw a nice parallel lines here. Okay, looks pretty good. All right, so with this information that you should know that, we've got two parallel lines, one pair of parallel lines, they are parallel to each other. Then according to what you have learned from the previous lesson about alternate angles, so let's identify the alternate angles here. So we've got an angle here, a bit too big. We've got an angle here. This angle is actually equals to angle C, all right, because that's called alternate angles. All right, so we can just label the angle C here. Okay, excuse me. Angle C is there. Now, similarly, on the other side, this angle here is equal to angle B. All right, so we can move the angle B to that. So now you can see here that angle A, angle B, angle C are joined together, and those three angles join together to form a straight line, and that's why angle A plus angle B plus angle C is equal to 180 degrees. All right, so that's a very simple geometric proof. All right, so that's the first property of a triangle. So, right, that I hope like everybody actually understand this. Angle sum of triangles is always equal to 180 degrees. All right, so the second property of triangles, we're talking about the exterior angle of a triangle. So let me just draw a shape of a triangle first. All right, so what does that mean is if we have A, B, and C, or A, B, and C, we've got these three angles there. It's called the exterior angles theorem, okay? I'll just write this one down first. And it's actually a really useful theorem for anyone want to remember, and you can use it, of course, when it comes to do the questions. So the theorem says the exterior angle, okay, the exterior angle of a triangle, all right, is equal to the sum of the two opposite interior angles. All right. Sometimes it's pretty hard to understand from the the wording here. I'm just going to draw the diagram for you, and then you should be able to see what does that mean. So the exterior angle, okay, so I'm just like highlight the important words. The exterior angle of a triangle, okay, exterior angle of the triangle is equal to the sum of the two opposite interior angles. Okay, so what does that mean is if we extend the line here a bit, we've got this exterior angle here. Now let's call this exterior angle is angle D. So this, according to the theorem here, the angle D is equal to the sum of the two opposite interior angles. So we've got three interior angles. Alright, the opposite interior angle then this angle here, which is these two, angle A and angle B. So angle D is equal to the sum of angle A plus the sum of the angle A and angle B here. And that is what the property of this is about. Okay, now how do I prove this and why this is true? It's actually pretty straightforward, all right? If you think about this, angle D, all right, what's the reason why angle D is equal to angle A plus angle B? Well, if you look at angle C, Alright, angle C plus angle A plus angle B is actually equals to 180 degrees, right? And that's just the proof. That's the property of triangles here. So therefore, angle A plus angle B, or should I just write? Therefore, angle C is equal to 180 degrees minus angle A plus angle B. If you just move these two terms over to the other side, you end up with this, right? Okay, so then how do we know that, that is equal to angle C is equal, angle A plus angle B is actually equals to angle D? Well, if you look at this property here, okay, I'm just using this color here. We've got supplementary angles. So we already know that angle C, right, also angle C is equal to 180 degrees minus angle D. Okay, so therefore, once we know this, set up this property here, then we can just confirm that since these are 180 and 180, they're both 180 minus, therefore, these two must be equal to each other. So therefore, at the end, you can see these two, terms here is equal to each other, which angle D is equal to angle A plus angle B. Now, you don't really need to know how to prove this one at this stage. You just need to know how to use this property here. Okay, so I would like to show you like a very simple example of this property. Okay, so what does that mean? So if you have like a triangle, any triangle, if this angle is equal to 30 degrees and that angle here is equal to I don't know, 135 degrees, and if the question asks you, hey, what is this angle A equals to, then you don't have to actually calculate the angle here, then use the angle here with this angle there to calculate the angle A. So you can use the property. We know that this exterior angle of a triangle is equal to the sum of the two opposite interior angles. So the angle here must be equal to this 30 degrees plus A. So all we have to do is angle A plus 30 degrees is 135 degrees. So angle A is equal to 105 degrees. Obviously, it's not true because I didn't really set up the question properly. As you can see, that angle is an acute angle. It shouldn't be 105 degrees, but I'm just using this as an example to demonstrate, okay? So I'll probably change the value here. That's not 30. That's definitely looks like a 50 to me, but let's just say that's 60 degrees. So if that's 60 degrees, then 135 minus 60, that is 75 degrees. That looks much better. Okay, so this is what you do, all right? So it's actually pretty easy, questions. It's not that hard at all. I think I'm just going to do a few examples to show you. I'll just grab some example question from the textbook. Maybe 2 examples is enough for this lesson. Example 1, I'm just going to pick a question from the textbook, okay? It will be this question here, looks pretty interesting. Alright, so it's question 10F. Alright, from the exercise, which exercise is this? From exercise 6C. Alright, so 6C, 10F. But the simple question, the question asks you to calculate the value of missing angle A inside. Okay, so you've got a diagram. Just going to draw a diagram first. So this is the diagram. That's a 90 degree. Okay, so that's question F. Here's A here. This angle is 150 degrees. And the question asks you, what is the value of A? So that question is super easy. Well, if you know the exterior angle properties, that's the exterior angle is equal to the sum of two opposite interior angles combined. So therefore, A plus 90 degrees is 150 degrees, and A is equal to 60 degrees. So that's a very simple and easy question. I don't think you'll have any issues with the question like this. So that's pretty easy. I do like to try maybe a hard question for the, to sort of like conclude this lesson here. I'm gonna do a question where, let's see. Oh yeah, that's a good question. Now it's an enrichment question, so question 16. All right. So the next one is example 2. And question 16. A and B, okay? So I'm going to draw the diagram first. There's a circle here. Oh, I can move the circle bigger and smaller. Okay, change the circle size. Alright, so we've got a circle, and then Here's the center of the circle. There's a diameter passing through the center of the circle. And then we've got a triangle like this. And here we go. Alright. Alright, so let's just label all the information. That's 30 degrees. That's A, here's C, and here's B. Pretty sure the question asks you to find out what is the value of A, B, and C from the diagram. Okay, alright. So how would you do that question there? Well, firstly, the information here is like you need to find more information from the diagram. At the moment, if you don't find more information, there's no way I can do it. Well, the question says using the property of our isosceles triangles. But where's the isosceles triangles? If that's the center of the circle, then this is the radius of the circle. That's also the radius of the circle. So the two radii must be equal to each other. Actually, that's also a radius of the circle as well. So they're all three of those radii must be equal to each other. So that means if we mark those, they are equal to each other. So that means if I highlight this triangle here, this is an isosceles triangle. So if this is an isosceles triangle, then the first question is really easy. Angle A must be 30 degrees. These two angles must be equal to each other. All right, the base angle of isosceles triangles are equal to each other. Then on this side, we've got another triangle that's an isosceles triangles here. Okay, but unfortunately, from here we can only say, hey, I don't know what's the angle C equals to. I still don't know what's that answer, but that's okay. Once we know A is equal to 30 degrees, we should be able to find out what's this angle here. All right, we can use the angle sum of triangles to find out this angle. All right, now, what's this angle? Let's just label this angle as angle E. Angle E is equal to 180 degrees minus 30 minus another 30, so that gives you 120. All right, once you look at angle E is 120, we can find out what's angle B. Because angle B and angle C join together to form 180 degrees. All right, so that becomes 180 minus 120, that's equal to 60. All right, so if this angle is equal to 60, can we find the value of C? All right, yes, because these two angles are equal to each other. So therefore, angle C is equal to 180 degrees minus 60. That's the angle sum of triangle. And shaded by the two angles there. So therefore, divided by 2. So at the end, 30 degrees. All right, so this is an enrichment question. But to be honest, it's not that hard at all if you know the property of the triangles. Okay? All right, that's all for this lesson. It's a simple and short lesson, exercise. So you should be fine with this lesson here. All right, thanks for watching.